Okay, so chapter 10 opens up with graphing quadratic equations. So up till this point, we've only ever graphed linear equations. So if you have your coordinate axis over here, a linear equation is going to look something like this. Linear would be a straight line, so y equals mx plus b. That type of equation would be a linear equation. But a quadratic equation or a quadratic function looks something like this, as we've seen before. Y equals ax squared plus bx plus c. And this would obviously be where a is not equal to 0, because otherwise it would just be a linear function. So when we're graphing a quadratic function or a quadratic equation, we call that shape that it forms, it's a U shape, and it's called a parabola. So if you ever hear the term parabola, you're picturing something like this. It's a U shape. Now, if your a value is positive, so in this case y equals 3x squared minus 6x plus 9, our a value is a positive 3, the graph is going to open up. And you can think if it's positive, it's happy, it's going to be a smile. Just kind of a silly way of remembering that. If your a value is negative, however, you have y equals negative x squared minus 2x plus 8. It's negative, so it's feeling sad, so it's a frown. So if your a value is positive, you're opening up. If your a value is negative, you're opening down. So just breaking down some terminology when it comes to parts of a parabola or parts of a quadratic equation. The vertex of a parabola is going to be either the highest or the lowest point. Here it's the highest point, since our parabola is opening down. The axis of symmetry is always a vertical line, x equals something. In this case, x equals negative 3. It's always a vertical line, so x equals some number, and it's the x part of the vertex. So the vertex in this case is negative 3, 8. It's just a point. But the axis of symmetry is a line, x equals negative 3. Then we also have roots or x-intercepts. Sometimes these are also called zeros, and this is anywhere that your parabola crosses the x-axis. So in this case, one of the roots is 2, or the point 2, 0. Another root is negative 8 or negative 8, 0. So these are roots or x-intercepts or zeros. We have the vertex, which is our highest or lowest point. And then we have our axis of symmetry. And that term symmetry would mean it's symmetric about that line. So you notice this is a perfect reflection of the right side to the left side. So 10.1 specifically deals with quadratic equations that do not have an x term. So these look like y equals ax squared plus c. Notice we're missing that bx portion. We'll talk more about those later on in the chapter, but for 10.1, we're just dealing with things that look like y equals ax squared plus c. So if your equation looks something like this, to find the vertex, you're always going to start with an x-coordinate of 0. So in this case, we're using y equals 2x squared. So y equals 2, we're going to plug 0 in for x. 2 times 0 squared. Well, 0 squared is just 0. 2 times 0 is just 0. So our vertex here is 0, 0, which is right at the origin. Which was this next step. Whoops. Basically, we found our vertex is 0, 0. So we just found the vertex, but now to make our graph, we're going to make a table. So we need to plug in some points around the vertex. So we have 0, 0. And what's nice is, since our axis of symmetry is the x-coordinate of our vertex, our y values to the right or to the left of our vertex are going to be the same. So let's see how this works. If we were to plug 1 into 2x squared, 2 times 1 squared, that's just 2 times 1, which is 2. So we're getting some values in our table. Now just to show you, if we did 2 times negative 1 squared, we would still get 2 times positive 1. Negative 1 squared is positive 1, which is 2. If we were to plug 2 into our equation, 2 times 2 squared is 4. 2 times 4 is 8. Negative 2, I hope you believe me, your y value is just going to be positive 8 as well. Now if we were to plug 3 in, 3 squared is 9, 9 times 2 is 18. Negative 3 would give us positive 18 as well. The reason these values 2, 8, and 18 are all positive still and not negatives because when you square a negative 1, you get a positive 1. If you square a negative 2, you get a positive 4. A negative times a negative is a positive. So when we plot this, let's make our, there we go. If we're plotting this, we have 0, 0, 1, 2, then we have 2, 8. So over 2, up 3, 4, 5, 6, 7, 8. And we're just going to be able to reflect that right over because that's our axis of symmetry. And then lastly, we have 18. So we're going to go up 10 more from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our parabola is going to be fairly skinny. I'm going to try to do this okay. Get down to our vertex and curve it up. Ooh, getting a little off. I apologize that looks a little bit ugly on the left. But this is the general form of our quadratic equation. Once again, our axis of symmetry is x equals 0, which we saw on the last page. That just means that we're symmetric about x equals 0. So here is our parabola. Okay, let's look at another one. First of all, we can ask, we have y equals x squared plus 5. Is this going to open up or down? This goes back to that first slide. Up or down? Well, our a value is a positive 1, so it's going to open up. It's going to look more like a smiley face. Our vertex in this case, we have to plug 0 in for x. So y equals 0 squared plus 5. 0 squared is just 0. 0 plus 5 is just 5. So our vertex is at 0, 5. Our axis of symmetry is going to be at x equals 0. So we can put that in our graph first if we'd like. And then our vertex 0, 5. Let's do that in blue. 1, 2, 3, 4, 5. Here's our vertex. But now we need some points around that vertex. Well, let's plug in 1. 1 squared is 1. 1 plus 5 is 6. But what's nice is since this is our axis of symmetry, we know negative 1 will just be 6. Plug in a 2 now. 2 squared is 4, plus 5 is 9. Negative 2 will be at 9 as well. Let's do 3. 3 squared is 9, plus 5 is 14. So we'll have negative 3, positive 14 as well. So we said we had 1, 6. We have 2, 9. And we have 3, 14. And then we can connect our parabola. Let's try to do this a little better this time. Not terrible. Something like that, where our vertex is at 0, 5. We're opening up. Our axis of symmetry is at x equals 0. We have a couple more points. Now, I often get asked, Mr. Johnson, do I need to have 7 points? Do I need 3 points? How many points do I need? I typically say I want 2 points on either side of the vertex. So sometimes that works out to be 5. If you want more, go right ahead. But you can normally get a good idea if you have 2 points on either side of your vertex. Okay, let's try one more. If you want to pause the video, go right ahead and try this on your own. Okay, let's pick up on this. Probably go pretty quick through this one. first of all, does it open up or down? We have y equals, whoops, this should say y equals. It's an equation. Y equals negative x squared plus 8. Well, it's going to open down. Our a value is negative, so we're going down. Our vertex, if we plug 0 in, 0 squared plus 8 is just going to be 8. So our vertex is at 0, 8. Our axis of symmetry is going to be at x equals 0, like what we've seen this entire section. That will only be the case when you have something that looks like ax squared plus c. Our vertex we said was 0, 8, so 1, 2, 3, 4, 5, 6, 7, 8. So we're starting here, and we are going to be going down. If we plug in 1, we get negative x squared. I'll write this one out. Negative 1 squared plus 8. So this is negative 1 plus 8. So this is positive 7. So at negative 1 will also be a positive 7. If we plug a 2 in, we have negative 2 squared plus 8. That's negative 4 plus 8, which is just positive 4. You'll find if you plug 3 in, you get negative 3 squared, which is negative 9 plus 8, which is negative 1. So here we go. We have 1, 7, negative 1, 7, 2, 4, negative 2, 4, and 3, negative 1. Negative 3, negative 1. So there's our parabola. We have our axis of symmetry written. We have our vertex here at 0, 8. We have a couple points on either side of the vertex, and we are good. So your graph should look something like this. That wraps us up for 10.1. Fairly simple, actually, once you get a handle on squaring a number and not losing track of your negatives. With some sections coming up, things might get a little more complicated when we start to involve where b is something other than 0. But for 10.1, that will do it.